Hello everyone. So this video will be about the solutions of IGCSE Physics January 2021 session paper 2. Let's begin. So the first question, state two differences between light and sound waves. Light waves are transverse waves, sound waves are longitudinal waves. Light waves can travel through empty space, but sound waves cannot travel through empty space. Second one is picking the right option. Which of these electromagnetic waves has a longer wavelength than infrared waves? So we have to refer to the electromagnetic spectrum, and from there we get to know that microwaves have a longer wavelength than infrared. Then which of these is another use for infrared waves? They give one use, which is to see objects in the dark by doing infrared photography. So the other use is heating lamps, because infrared is used for infrared is emitted by warm objects. So if you have heating lamps, that is what infrared is used for. Anything which is related to heat, you go for infrared without looking anywhere else. Which of these is a harmful effect of infrared waves? Of course, skin burns. If you touch something warm, you're going to get burns in your skin. So in this one, you have to draw a trace to represent the sound wave produced by the alarm, which is a loud, high-pitched sound. So this is the dotted one is a low-pitched sound, which is quiet. That means it has a low amplitude, meaning it's quiet, and it has, small frequency. That means it's low-pitched. Now, if you want to have a loud sound, it has to be high amplitude, more than this. And if you want to have a high-pitched sound, it has to have more frequency than the one which is in dotted, right? So it has to have more frequency. That is what I did. Now this one you have to fill in the blank. So in here it's of course 2, because if you add them, you have to make sure that the left and the right hand sides add up to the same number. So the right hand side, the mass number is 236. So if you add on the right side, on the left side it was 236, on the right side it should be again 236. So 140 plus 94, we are left with only 2 to make it 236. So that's why it should be 2 neutrons. Now of course, whenever something decays, that is called the parent nucleus, and the thing into which it decays is called a daughter nucleus. So parent comes first, daughter comes later. So parent is uranium and daughters are xenon and strontium. Then describe how the neutrons released in this fission can cause a chain reaction. So of course, neutron release goes on to strike the uranium 235 again, and whenever the uranium 235 is struck by the neutron, the neutron gets absorbed by the uranium 235. Uranium 235 becomes uranium 236, and then it starts decaying, and after it decays, it again forms xenon, strontium, and again 2 neutrons, and this process is repeated again and again. So this is how you make a chain. This is how you cause a chain reaction, by repeating it again and again by following the same procedure. Now name an instrument that the student should use to accurately measure the distances on the clamp stand. So whenever you want to measure distances, you always have to use meter rule or measuring tape. Anyone is fine. Then you have to fill in the blank here. You have to find the missing value, and to help with that, they have given you this diagram. If you zoom in, you can see that at 45 centimeter distance, the force is exactly 3.6. That's what I wrote. Okay. Then give a reason why this Newton meter is unsuitable for measuring the force for distances less than 15 centimeters. If you look at the chart, for distances less than 15 centimeter, the force would be even more, because if the distance increases, the force decreases. So if the distance was even lesser than 15, the force would be even more than 10. And if you look at the diagram, it only reads up to 10 Newton. It cannot read more than 10 Newton. So that means it will exceed the range if the distance is less than 15 centimeters. So that is what I wrote over here. Now you have to draw a curve of best fit using these values. So that's what I did. And best fit means you have to make sure that the curve passes through as many points as possible. The curve has to pass through as many points as possible. Now the student concludes that the moment required to tilt the clamp does not change when the distance is varied. Use data from the table or the graph to evaluate the student's conclusion. I used data from the table. So I took several pairs of values. Let's say I took maybe 3 values here. 1, 2, 3. I took 4 pairs of values, right? So using 4 pairs of values, I got to see that the moment values range from 162 up to 168. So it's within a very short amount of range. And also you have to, because it's what 4 marks, you have to first say the moment is force multiplied by distance. So as distance increases, the force decreases to keep the moment the same. So if moment is force into distance, and you have to keep the moment the same, and if you're increasing the distance, to keep the moment the same, if you increase the distance, let's say by 10 times, you have to decrease the force by 10 times as well. Otherwise, the moment will not remain the same. Okay. So that's what I wrote here. That will give us the 2 marks. And the remaining 2 marks you're going to get from the calculations, which show that the moment is more or less within a acceptable range. That means the student is correct, because the student did say that the moment doesn't change. So it does change a bit, but it's not much. So it's respectable, acceptable enough to say that the student is correct, because the moment does more or less stay the same within a range of 162 up to 168 Newton meter. This one state what is meant by the term non-renewable, something which cannot be easily regenerated once used up. It takes millions of years to regenerate. Examples are coal, oil, and natural gas. So determine the percentage of electrical power generated using the non-renewable energy resources as shown on the bar chart. So on the bar chart, we can see three different types of non-renewable resources: coal, natural gas, and nuclear. If you add the percentages of all of them, you're going to get 82%. Explain one way that burning fossil fuels can be harmful to the environment. So burning these fuels result in the production of carbon dioxide. This gas mixes with the water in the air to produce carbonic acid. To be honest, it should be carbonic acid. So carbonic acid is something which falls with the acid rain, and it increases the acidity in the soil and the water. That's a bad thing. That harms the soil and the water, and that thing will eventually go into our body and we will be damaged, right? So then this one, calculate the mean electrical power output from solar energy resources. So if you look carefully in the bar chart, solar energy resources only constitute only 1.5% of the total energy generated, only 1.5%. So out of the total energy generated, which was 4.76 times 10 to the power 11, out of this only 1.5% was by solar energy. So we came to the conclusion that this is the amount that was produced by solar power only. Okay, pretty small amount. Then land used. Here they are telling you that every 1 meter square of land is capable of generating 250 watts of electrical power, and the United States needs these many watts of power per day, I believe, or per second, sorry, per second. So if you want to get this much energy, this much power rather, you have to see how much land is needed. So if every meter square produces 250 watts, how much land is needed to produce this much? So you divide this 4.76 10 to the power 11 by 250, you get this value, which is these many meter squares of land are needed to produce this 4.76 into 10 to the power 11 watts of power. Now the total land area of the USA is 9.83 into 10 to the power 12. So of course it's the land area that we need actually is much smaller than the land area available, right? So of course it's possible, but there are so many catches. The area needed of this is lesser than the total land of the USA. So if all the land was used for this purpose, and if the efficiency of the system was constantly maintained, it is possible to power the entire United States using solar power. However, now we move into the problems. However, not all the land can be used, because we have to make buildings and offices as well. Not all the land can be used for just solar power. People have to live there as well. And the availability of the sun is also not guaranteed. You cannot say the sun will be always available. The sun, it could be cloudy, right? It could be cloudy, it could be raining, whatever it is, we may not be able to get the sun at all times. And as a result, we will not be able to generate the entire energy requirement of the United States using just solar power, even though the land is available, but the sun is not. Then number 5 is about transformers. Give the name of the suitable metal that can be used in the core of the transformer. Of course, it's the iron core. Formula linking input power and output power. So input power would be equal to the output power. It maintains 100% efficiency. Now we have to find the input current. So VPIP is equal to VSIS. We know the input voltage, which is 275 kilovolt, 275,000, and IP, I don't know, I have to find it. And secondary voltage is 230, and the output current is 95 amps. So you have to make sure that you convert the kilovolts to volts. That is the tricky part here. That is where you might make the mistake. So we get 0.0795 amps of input current. Then explain how transformers are useful in the large scale transmission of electricity. So here I have to talk about both the step up and the step down transformers in the two different parts of the transmission system. So at the beginning, from the power station, once the electricity has been generated from the power station, the voltage is stepped up before being transmitted. Why? Since P is equal to V into I, power is voltage into current. If we want to keep the power the same, if the power is to be kept equal and you increase the voltage, the current will decrease. If you increase the voltage by 10 times, the current will also decrease by 10 times to keep the power equal. Okay. Now, if the current decreases so much due to lesser current passing through a long length of wire and facing resistance. So of course, when you transmit, of course, you're going to be having, let's say this is the power station and this is your home. So between the power station and home, there are like hundreds and hundreds of kilometers of wire, right? Hundreds of kilometers of wire. So if small amount of current flows through this much, if small amount of current flows through such a huge length of wire, because of the smaller current flowing through a large length of wire, even though the resistance would be more, because of the long length of the wire, the resistance would be pretty large. But because the current has been reduced by so much, even though the resistance is pretty large because of the large wire, long wire, still the heat loss would be substantially decreased. The only reason for this is because the current has been substantially decreased. So even though the long length of wire does mean a lot of resistance, but still because of this very small amount of current, the overall power loss due to heat is massively reduced. Okay, this means what? Resulting in more of the generated power to reach the output. So whatever bit of generation you got from the power station, a big portion of it will actually reach your house before, it will be able to reach your house by not losing much due to heat in the power supply transmission line. Then before it reaches your house, you have to step down the voltage. Okay, you have to step down the voltage by using a step down transformer, because your house doesn't require such huge voltages. Your house requires only 220 to 240 volts of voltage. This is from the Hertzsprung HR diagram. Okay, so star W is a white dwarf. So white dwarfs are, of course, they have lesser luminosity or brightness as compared to the sun, but they have more temperature. So their surface temperature is more. That means it's going to be it's going to be beneath the sun, because beneath the sun you have, so not beneath, more like to the left of the sun, because as you go to the left, the temperature becomes more, and also because it is lesser in size as compared to the sun, because it's a dwarf, and a dwarf star is smaller in size than the sun. That is why it should be below the sun in the Hertzsprung-Russell diagram. That is why the sun is here, but the W is bit below the sun. Okay, so it has to be to the left, because on the left the temperature is more. That is the property of the white dwarf, and also it's smaller than the sun, so it has to be beneath the sun. Star X is a red giant. So red giant means it's larger in size than the sun. That means its luminosity is more, or brightness is more. That's why it has to be above the sun, and also it has to be to the right, because its temperature is lesser than the sun. As you go to the right, the temperature decreases. Star Y is a main sequence star that is much larger than the sun. So main sequence means what? This entire thing, if you draw the sketch of it, this entire thing is the main sequence, right? So of course it has to be on top of, above the sun. It has to be above the sun because it falls within the main sequence, and also because it is larger than the sun, it has to have more brightness. That is why it should be on top of the sun and a bit to the left, because it has to be falling within the main sequence trend, right? This is the main sequence, so it has to be falling within this, so it has to be a bit to the left. Then star Z has the same surface as the surface temperature as the sun, but would be dimmer if it were the same distance away from Earth as the sun. So basically in here they're telling us that the temperature is the same, however the brightness is going to be lesser. If we take the Earth as the central point, and from the Earth, let's say this is the Earth, and from the Earth we are judging both the sun and that other star, which is Z, we are going to find that star Z's brightness from the Earth, it looks much lesser as compared to the sun. That means what? That means star Z is, it has a lower brightness as compared to the sun. When we take the Earth as the reference, from the Earth, the sun has a more brighter situation than the star Z. So because star Z looks dimmer, it has to be lesser in brightness. That is why it is beneath, exactly vertically beneath the sun. Why is it exactly vertically beneath the sun? Because not only is its brightness less, that's why it's beneath the sun, but also because it is having the same surface temperature. So that means if the sun is yellow, the star Z will also be glowing yellow. It has to have the same temperature. That is why it is exactly vertical and not to the left or to the right. Okay, if it was to the left or to the right, that means the color would have been different, the temperature would have been different, but they're telling us the surface temperature is exactly the same as the sun. That means it has to be exactly beneath the sun, and it has to be maintaining the same color code as the sun, because the color code gives the temperature. So if it's right beneath the sun, that means it is following the same color code as the sun, which is yellow, and that means it has the same temperature as the sun as well. Okay, so next one, why is the moon not included in the Hertzsprung-Russell diagram? Long story short, the moon is a satellite. It is not a star. The HR diagram only displays different types of stars. Number 7, initial momentum. Here the ball A is moving towards the magnet, and once it pushes the magnet, ball C will take off. Okay, so initial momentum of ball A, the mass of the ball A is 4.1 gram. Convert this to kg and then multiply this with the velocity. You will get the initial momentum of the ball A. Then ball A is attracted to magnet. How this attraction affects the momentum of the ball as it approaches the magnet. So as the ball A goes close to the magnetic field, because the force is increasing, as you go closer to a magnet, the force on you will of course increase. So that is why, because the force on ball A is increasing, that means it will accelerate, and if it accelerates, that means its velocity would be more. If its velocity would be more, that means the momentum will also be more. Then once ball A strikes this magnet, ball C takes off. So if ball C takes off because it was exerted with a force of 1.3 Newton by ball A. So this is the force, and they're asking us to find the change in velocity. So we know the force, and we know the formula: force is change in momentum by time. So change in momentum means what? Final momentum minus initial momentum. So I know the mass. To of course find the momentum, we need the mass. We need mass, and using the mass, we will use m into v minus u, because change in momentum means what? mv minus mu. So if I take, in place of mv minus mu, if I take m common, I get v minus u. Okay, so I already know the mass, which is 4.1 grams, and v minus u I have to find the change in velocity. The time is 0.0025, which I wrote. So from here, v minus u comes to this much, which is the change in velocity. This is how much the velocity has increased. Now number 8, this is the last question. This is an ink drop falling through an inkjet printer plates, a bunch of plates. So of course the negative will go towards the positive, opposites attract, and it will repel away from the negative, because like charges repel. You have to show the path which it follows before falling onto the paper. So of course it will go this way. It will follow a parabolic path. It will follow a parabolic path, meaning it's going to go closer towards the positive plate and far away from the negative plate, and eventually it will fall onto the paper. So it has to follow a parabolic path away from the negative plate and towards the positive plate, and you have to give the arrow, of course, otherwise it's totally invalid. Calculate the horizontal acceleration. So acceleration is force by mass. You know the force, you know the mass, divide them, that's it. The ink drop has no initial horizontal velocity, so that means u is 0. Final velocity after passing through the charge place, 3.9, and the acceleration we already found, 7727. Put it here. The distance, horizontal distance, is 0.984 millimeters. So this one has to be converted into millimeters. Everything here is in meters. So whatever value I got, I basically multiplied that with 1000. That will convert the meter into millimeter. That's my answer. Okay, by the way, this should be 0.984. Okay, it should be 0.984 millimeters. That's the answer. The next one, last part. Explain how another ink drop could be deflected in the opposite direction by a greater distance using the charge plates in the inkjet print. Two things to be noted. Deflected in the opposite direction. If you look in the diagram carefully, it was deflected towards the positive plate. Now if I want to deflect it in the opposite direction, that means if I want to deflect it towards the negative plate, of course I have to choose a charged ink drop which is positively charged, right? Because only a positively charged ink drop will go towards the negative. A negatively charged ink drop cannot go towards the negative, right? So we have to use a ink drop which is positively charged. Only then it will go towards the other plate. And also they are telling us that it travels a greater distance. How can something travel a greater distance? If it has a lesser mass, if something is lighter, it's going to move faster, and it's going to move a greater distance within the same amount of time. So if I make the new ink drop lighter than this current ink drop, it's going to travel faster, and as a result it's going to travel more distance in the same amount of time. So we have to use a less massive ink drop. So that is the final part of this paper. Thanks for watching.